Hello, I'm John Ball. I'm the founder of Pat Labs, and today what I want to do is just a quick walkthrough of the language calculator, or what we're calling it, the early access for universities and people interested in natural language understanding. Okay, so let's go and get into it. We have here a number of options. You can see that we've got a home screen, introduction. So the home screen is just the welcome to the language calculator. The introduction talks about what it is, about pattern theory and role and reference grammar that drive our architecture and our decision-making process, what you get with early access, and conversation in the future, what that's going to look like. So then the next two elements, I'll just go to the meaning element first. This one takes sentences and breaks it down into its meaning representation. So if I were to say I am here as a sentence, you can see here that the where location that I am at is here, and we can see here that there's a space. It's a rather than a temporal example, and so we've got here is where I am. So I am here, and that's the meaning introduction. But language and recognition is more than that. If I click here on the phrases and then I choose the I am here option again, you can see now we're getting a breakdown of the phrases that we found. I am here. We get the phrases that follow the word am and the phrases that follow the word here. So when we look at the phrases that follow I, you can see some of them are just the I itself. And this is now selecting all of the options. You can see here, we started with I, we then recognize I plus am. These are different intermediate products. I am here. This is another intermediate product. And here we've got a semantic set. So this is the meaning representation of the whole thing. But we make the matching process transparent so that you can work with it. When I click here on more, I'm here, you're getting the same representation that we saw for the full representation. And that's because what we're looking for in the language isn't the intermediate steps that are taken, it's the final result. And in this case, we've got one final result. Now, if we move to the conversation engine, this works the same way. If we said, this is Beth arrived, she saw Sam. If we just put in those two sentences, any time the system recognizes a statement, we add that to context. And anytime we enter a question, we just look at the context and then we interpret what the answer should be. So here all I've done is add two statements. And if we look at the current context, you can see that we've got Beth arrived, she saw Sam. Beth arrived means that Beth is now at some location that we haven't specified, because we said she arrived. We didn't say she arrived, I don't know, at the house or something. So it's just representing what we've just said. And then she saw Sam is she sees Sam. And at this point you go, well, that's not very helpful, because what does she represent? But if we go into the details here, we can see that she is the location pronoun and Beth is now sitting there in the location. So that the first argument here is the location. So we're saying Beth saw Sam. And each of these definitions is the meaning representation for what we're looking at. And let's just keep stepping through. We've got an analysis screen, which is a bunch of conversation examples and a bunch of meaning matcher examples. If we take an example of, say, context, we've got this sequence: who arrived, Beth did, Beth arrived, who arrived. So as we run through all of them, and I'll just as a way of introduction, you can do this yourself.
Beth did.
As we enter these things in sequence, when you say who arrived, the answer is I don't know, because we don't know who arrived.
Beth did.
But then when we say
John
Beth
did.
arrived and we ask that
Yes,
question
She
again,
did. Yes, she did.
you just wait until
I
this
don't know,
finishes, and
but
then
he did.
I'll take you through what we're seeing. Okay. So now here we've got who arrived, I don't know, because nothing's in context yet. But when we add into context Beth arrived, we can respond, yes, okay, yeah. So, I am tall, we just provide a response. But there's not a lot of response that you give when people are giving you facts. But then when we say who arrived the second time, notice that in context Beth did, and then we add John arrived into context. And when you say who arrived, Beth did and John did. Now, probably that should say Beth and John did, but we're experimenting with responses, and this is more precise, even though a bit annoying, because we don't like to have verbosity in language. Sue and Dana arrived, and then when you say who arrived at the end, Beth did, John did, and Sue and Dana did. So that's simply answering the questions. When we look at the current context here, you can see we've got those three facts. Beth arrived, John arrived, Sue and Dana arrived, and we're getting the same semantic representation for each of them, and we've got three examples, so we've got three elements there to track as context. But when we ask a question like who arrived, at this point, notice that we're getting Beth, John, and Sue and Dana did arrive. Did Sue arrive? So we can summarize the whole current context, and we can then drill down into it. So did Sue arrive? Well, we knew that Sue and Dana did, so Sue also did, and we get the correct answer. She did. Did Dana arrive? She also did. Does John arrive? I don't know, but he did. So this is one of those strange things about the precision of language. Does John arrive? Well, I don't know if he does arrive, but he certainly did in the past. So he's not arriving now, but he did in the past. And that's the way in language we would produce that response. So that's an example of this analysis. And we've got a whole bunch, such as I'll only show you one example. A shark bit the surfer savagely at the beach yesterday because it was hungry. And then if we asked a question like, where did the shark bite the surfer?
At the beach.
It was at the beach because the shark bit the surfer at the beach savagely. So we're able to pull apart the meaning and then target a question about some particular aspect of meaning, even though it was all bundled together. And again, if we look at the current context, we can see there's the shark biting the surfer, and it was hungry. It feels hungry. And we can see here that the shark was hungry because we're resolving the pronouns as we go. Now, the next part is basically the overview of the different ways of recognizing our communication. So here we've got a bunch of semantic elements. We've got things that are more about the word sequence, particularly for English. And then we've got discourse examples. So working backwards, if we look at pronoun resolution, the example that I showed you before comes from the Roland Reference Grammar, one of the early books. But here, if we click on this is the conversation example. So here's what will come out in conversation. Beth arrived, she saw Sam, he kissed her. But here's what comes out if we were just resolving something in the meaning engine. So you can see the meaning engine is here, but you can't resolve a pronoun sensibly, or I'm not giving you examples of resolving pronouns in a single sentence. It's more as we're progressing through a conversation. So here we could enter this example of the sample sentence. So that's given us three elements of context. If you want to check, there it is. Beth arrived, she saw Sam, he kissed her. And if we wanted to see who kissed who in detail, we would come here and we see Sam kissed Beth. So we're tracking context as before. And in this conversation, I can then say, who saw Sam? We've got she saw Sam, so that should be Beth, I would think.
Beth did.
Beth did. So that's an example of pronoun resolution. So that was from the discourse collection. And we've got syntactic options like junctures. Let's look at one of the more complicated ones. So again, these are the ones that are representing conversation, and these are the ones that are just breaking down a sentence. So if Beth was promised by the girl to buy a car from the dealer because you speak English, the question is, what does this mean? Let's see, was promised. So the girl promised Beth to buy a car. So the girl's going to buy a car from the dealer. That's what it says. So if we select that, we can say the meaning of it is Beth was promised by the girl. So the girl promised Beth. That's the way that we represent it. And what that says is that Beth says something to the girl, which causes the girl to become obligated to do something. The X is the something that is obligated. So here's our juncture line that separates this part of the sentence from the rest. And the rest is the X. So then the girl buys from the dealer a car. So the recipient is the girl. The thing that they're buying is a car, and the thing doing the that has the car at the moment is the dealer. And we can see here the logical structure for this part of the sentence is that the girl does something which causes the girl who doesn't have the car to have it, and the dealer who did have the car to not have it. And so we then get the full meaning representation. And if we were to use that in a conversation, if you said, who bought the car? The girl promised. Well, we're seeing here that the girl was obligated for the girl to buy the car. So I'm giving you the most difficult example there. So the final piece is semantics. So we can break down different types of sentences. Source of information, is explaining to the person you're talking to, where did that information come from? Here, John is happy in the kitchen plainly. So it's plain. You can see that's what happened. Or Beth is obviously not marching. Obviously, Beth is continuously moving to the kitchen, slowly, apparently. So let's have a look at this one. So it was apparent. We can see here at the very outmost layer, it was apparent or evident. It was evident that the rest of this, slowly, Beth moved, covering a path that finished in the kitchen. So Beth is in the kitchen at the end. So there's our breakdown there. So that takes us through categories. Feel free to work through all of those examples. They are all expected to be in our test suite. So when we release new versions of our software, all of the tests should mean that these all work correctly. But again, this is the early access program, and part of the thing that we might notice is errors from time to time. What's the word sense? Excuse me. Well, so there can be predicates like cough and reference like water. A predicate is something that relates other things, other elements in language, and water is a thing, it's a reference. If we look at the forms of water, you can see here that we have a definition. We don't use the definition in the system other than to know what we're talking about. It's a binary compound. It has a hypernym. It's a kind of entity, and it's also a kind of volume. It's a three-dimensional space. Water. You can't have water sensibly that is completely flat, two-dimensional. And then we don't have water and waters in normal speech. If you're talking about water, it's singular and plural. You don't say waters. Not in this particular sense. And if we now, let's see, go back. Oops, where are we here? Go back to our list. So that's an example of a referent, and an example of a predicate is here. Predicates are more complicated because they determine what their arguments are. So in the predicate cough, you can see here that we have a symbol for it, p:\cough. This is language independent, but for debugging, it's good to have something in my language so that I know this represents the predicate cough. This tells the system it's a predicate. There's the definition here that tells me as an English speaker what it means. We don't use it to recognize things. It's an activity, not a state, from the role and reference theory, and we write this symbol cough when we generate the logical structure. Now, because it's a predicate, it defines what its arguments are allowed to be. It helps us understand in a long sentence what makes sense and what doesn't. So we're allowing the actor to be a person or something that's animated. So a robot can cough, a person can cough, a dog can cough, they're animated, and we then allow it any sort of syntax that aligns with a one-role activity. Won't explain how that works for now. And then finally, in terms of its meaning, it's a one-role predicate. It's not causative by default, and it's simulfactive, meaning when you cough, it's an activity. There's no change of state. So you cough and then you're back to normal. There's nothing that's changed as a result. And it's positive polarity. So if you cough, it's, not coughing, as in, unhappy, uncough, whatever that would mean. And here in English, we're not doing the word breakdowns at the moment with a system. We're simply taking one of these set elements because fundamentally that's just a different level of recognition. And so we're not trying to simulate it here. And finally, help. If you wanted to look at some help text, this is what the system's doing. Okay, so that's the quick introduction with some examples of what the system does while we're using it. There's lots of other videos where we'll go into the detail in a bit more specificity, to use a long word. Thanks very much for joining me. Again, I'm John Ball, and see you again soon. Bye for now.